Okay, today we're talking about geometric sequences, and right now what we're going to do is we're going to say that a geometric sequence, each term after the first differs this time by a common multiplier, and that's called a common ratio. Okay, last time it was common difference because we added and subtracted it. This time it's a common ratio because we multiply, divide. What that's going to be equal to is the nth term, any term you like, divided by the nth minus 1 term, or the term before it. So, if we look at this sequence up here, what you can see is that if you do 2 divided by 1, or the second term divided by the second minus 1 term, or the first term, 2 minus 1 divided by 1 is 2. If you do the third term divided by the second term, or the third term divided by the third minus 1 term, the second term, 4 divided by 2 is also 2. 8 divided by 4 is 2, 16. They're all creating the same common ratio. So, what we do with that is generally you just take the second term, divide by the first term. But that's got to be true for all of them for it truly to be a geometric sequence. Now, the other thing to realize is that a geometric sequence is an exponential function. And it's an exponential function with domain of the counting numbers again, just like it was before. So again, like we were saying, the first, the second, the third, the fourth, the fifth term, and so on. So how we find the general term of a geometric sequence is found by, get that up there, geometric sequence, a sub n, or the nth term, any nth term, is equal to the first term times r, the common ratio, and that's up there, to the nth power, minus 1. So notice up here, the common ratio is r. That's the r value here. So you're just multiplying that r to the n minus 1 power times that first number. So let's go ahead and try some examples here then. So let's go ahead and let's find a sub 6, or the sixth term, if a sub 1, or the first term, is 1 and the common ratio is 2. So over here we're going to follow this equation. So the a sub 6, or the sixth term, is going to equal the first term, which is 1, times the common ratio, r, which is 2. And we're going for the sixth term. So we're going to do the 6 minus 1 power. That's this formula over here. So remember the order of operations. We still have 1 times 2 to the 5th power. 1 times 2 to the 5th power is 32. And finally, 1 times 32, we get a final answer of 32. And that is the sixth term. Notice up here the first term was 1, the common ratio is 2, just like we said here. We're looking for the sixth term. 1, 2, 3, 4, 5, sixth term is 32. So now let's go ahead and find the first term. So find a sub 1 if the sixth term, a sub 6, is 32, and the common ratio is 2. So now what we're trying to do is we're trying to find the first term when we know all the other parts. So the last term is 32. The first term we don't know. The common ratio is 2. And we know that this gave us the sixth term, so n would be 6 minus 1 power. So we get, let's bring that on down, 32 equals a sub 1 times, now 6 minus 1 is 5, 2 to the 5th power is 32. We would divide both sides by 32. 32 cancels, and there it is. A sub 1 is actually 1. The first term is 1, just like up here. Now let's go ahead and find a common ratio. So find R if the first term, a sub 1, is 1, and the sixth term, the sixth term, so a sub 6 is 32. So we're trying to find the common ratio. So we got the first term here, we got the sixth term there, but they've also told us n, the number of term. So 32 equals 1 times r to the 6 minus 1 power. We divide out the 1, we still have 32 equals r to the 5th power. And then, of course, hopefully we remember what we would do is we would take a 5th root of both sides. Now, if you can't do that in your head, if you have difficulty with that, remember you can always use the change of base formula, do a logarithm and all that kind of thing. But what we end up finding is that r equals 2. The 5th root of 32 is 2, and that's the r value. Again, up here, that's our common ratio. So our last example for this video is finding n. So find n if your first term, a sub 1, is 1, your nth term, a sub n, is 32. So notice I'm not going to tell you what n is right there, and r, the common ratio, is 2. So again, we plug in what we know. The nth term is 32. We know the first term is 1. We know the common ratio is 2. We just don't know n minus 1 power. So we would divide both sides by 1 and still have 32. We would then do a logarithm, basically, because think about this. We're going to have 32 equals 2 to the n minus 1 power. As a logarithm, we could rewrite that as log base 2 of 32 equals n minus 1. So now to get n by itself, you just add 1 to both sides, and we get log base 2 of 32 plus 1 equals n. And realize that 1 is not part of the logarithm. I'm going to exemplify that with the parentheses here, even though I do not need to do that. And then we can go ahead and solve that. Notice log base 2 of 32 actually does equal 5. So we get 5 plus 1 equals n. And there is where we finally find that n equals 6. And there's our n value. So that's how you can solve for any of the 4 variables in the geometric sequence general term. I hope this helps out. Give me a ring if you have any questions during video conference, and I'll help you out then. Good luck. Bye-bye.